All right.
We're bringing you guys an update here on December 26th, the 6th day of the eruption of Kīlauea. So, yeah, in case I got cut off here to start, I'm Philip Ong. I'm here with Dan DuPont. We're gonna cover this day 6 of the Kīlauea eruption, and start you guys off here with this video. It was taken between 2 and 5 a.m. this morning Hawaiian time. So, maybe 12 hours ago-ish. And you can see this view's taken. Here's the main active vent earlier today, the start of the day, and the second one was over to the western vent. This is that main northern vent that you can see the lava level has come right up to it, and actually most of the lava is draining back into it. This vent's been dying off in intensity, and in fact by now is all the way shut off. But this video from this morning is kind of showing the last gasps of it before it actually did shut off. So this is that northern vent within the pit of Halemaumau in Kīlauea caldera volcano on Hawaii Island. And this eruption's now going on 6 days, and it's put out a pretty amazing amount of lava. It's been astonishing to watch how it fills this whole crater. You guys can hear the sound of the wind and the gas jetting and the roars of the fountain here behind me. And that's what's going on over there with the USGS video. So now we're looking at the northern vent. I think they could use some windscreens in their mics, huh? I won't talk over the wind.
Same thing, turning off the helicopter ambient noise.
All right, okay, better set on this one. I want to try it. Yeah, so here's that western vent that's higher above the crater wall. We've heard from USGS it's about 111 feet higher than a current lava level, and the other vent that's being drowned, you can see it's putting out a good amount of lava still, flowing down from these two different eruption points down in these kind of rapids that are sloshing kind of below the crust of that solid lake that you see here, right? You can kind of see the cracks revealing that molten interior, but there's that crust forming it that's a few inches thick, more than likely. You don't really see it undulating or heaving so much in this image, right? Sometimes you do see that in the more active, vigorously bubbling lava lakes. So depending on how much circulation happens, you can kind of see the crust start to form and get thicker, and the lava accumulating in the walls of the crater and kind of coming inwards, and we'll see some of that as well here. So that's the video we have from the USGS today, and I'm going to go over here and show you guys. This is a webcam view from about an hour ago, right? As it was getting dark, and I've kind of been saving this to kind of show you guys to show you how you can see now in this video, or in this image, how this is the northern vent. We're now looking from kind of back to the southeast, almost like, you know, maybe west to east, or northwest to south, somewhere in that orientation. So this northern vent over here is all dark, and you can kind of see the lava levels all the way up to it, and kind of incandescent all to the edge of it. You know, we don't really see any red down here anymore. We do see more glow coming from this western vent, right? It's kind of straight down below the field of view of this camera, right? And so it's hard to tell exactly what's happening in the interaction. We can't really see any of that rapids we just saw in the video, but that's all kind of coming from below here down this very, very steep angle and field of view into the lake below right there. So and you can kind of see some other views. You really don't see a whole lot of glow in the sky quite yet, an hour ago, right? And there's that thermal. We'll talk about that here shortly. But I'm going to come back up here, and I'm going to reload this page and show you guys what that looks like now that it's gotten darker here on Hawaii Island. And of course, the camera has to switch its mode, right? So you don't really see the color anymore. You just see kind of it's almost like the brightness indicator where the lava is, right? You can see the lake is still very active all through there. You can see that's that island that's still in the middle there, and this is actually a little chunk of it with a little lava flooding the little gap between them. And lots of little different crusts, pieces of crust on the lake, right, that are over there, right? So there's kind of, you know, I'm not seeing a whole lot in the middle here. I'm not sure if that's because it's overexposed or if there's more lava flowing in from that direction. It's hard to tell exactly, right? If there was an increase in the vent, you might expect more breakout of the crust. But we're still waiting to see more imagery from USGS. So if you guys are just joining us for the first time, you know, we cover all the imagery from USGS, the monitoring signals, all of that, you know, so this is all USGS imagery. We're just trying to give you guys some interpretation and education, more in depth that might be of interest to you guys. And so here you can see the wide angle cam is actually showing more glow in the sky, and that's why there's so many visitors being attracted to Hawaii Volcanoes National Park today, right? And Hawaii Volcanoes National Park, you know, has their own webpage which talks about all the different ways you can visit and what you should watch out for and hazards and what areas are open and closed and consequences and all those things like that, right? So our most recent thermal image right here, you can kind of see we're also missing that northern vent. It's really hard to see anything on a southern wall over here, right? But if that thing is depending on how it spatters, we may not see it very easily from this angle. So I like to switch and, let's go back up to this one, right? So very hard to see what's happening here because of this brightness, but fortunately we have we have a very amazing community, right? And one of the members of our community is a photographer, Harry Durgan, and what he's done here is he's taken the USGS webcam image and he's processed it. And so it's given us a fantastic view of what this might actually look like in real color, right? So you can see here is that western vent and northern vent has died off as well. And you can kind of see all the sulfur all on the walls all through here, right? So that's a magmatic gas that escapes from the magma as it comes up and bubbles out. And that's a lot of the gas coming out of these vents is sulfur dioxide, which we'll talk about shortly, as well as water vapor, as well as carbon dioxide. Yeah, those are the primary, lots of other stuff, but those are the primary ones right there. Another member of our community, also posting on Facebook, also on Hawaii Tracker, is Bob Martin, who I met today. It's nice to meet you, Bob. And he put up this time lapse of the KW cam I'd like to share with you guys here. So just in 18 seconds, this is the past 3 days, right? Taken from the Kīlauea cam. And instead of the USGS time lapses that are issued on the website automatically, one frame every hour, he's actually got images every 20 minutes. So you can really see in better resolution the changes in the circulation patterns of the lava lake. And so I encourage you guys to go and check that out on your own, and you can study it as well based on your interest in a volcano. So thank you, Bob, for this fantastic time lapse. You guys can look for more of those on Hawaii Tracker. Hawaii Tracker Facebook group is where this one in particular was posted. So we're going to go to the update here, and we will read what the USGS has to say about the development and activity here. And so what I have here is actually the update from today. I'm going to scroll back down, and I had to do I went to the search archives and I pulled up the one from yesterday as well, right? So we're catching up from yesterday because we skipped Christmas Day. We didn't do an update yesterday, and we wanted to actually catch you guys up here. So last night, the Crater Lake was 577 feet deep. High SO2 emissions continued, 176 meters, right? SO2 was still high. They estimated it still at 35 to 40,000 based on what they measured on Monday and revised on Wednesday, right? And then essentially kind of scrolling down here a little bit, they had an increase of 6 meters or 20 feet over the previous 24 hours. That's to Christmas morning, right? And they also gave us a nice volume, right? The lava lake volume this morning, December 25th, was about 21 million cubic meters, or 27 million cubic yards, or 4.8 billion gallons, depending on your choice of unit there, right? So 27 million cubic yards might be something I come back to later on here, but that's it's a massive amount. Of course, it doesn't come near to refilling the amount we've lost in 2018 through the collapse, right? We're still like in the single percentage point kind of range of how much we've refilled. So they also mentioned here the island of lava within the lake is beginning smaller and drifting slowly northeastward in the lake. At this point, it was drifting northeastward still, right? Christmas Day. It's changed since then. We'll look at that shortly. It's about 260 meters in length, 850 feet in length, right? So almost a whole. Yeah, that's a big. It's almost as big as the old lava lakes what we talked about in our last update, right? Old lava lake at the top of Halemaumau in 2018 was getting similar dimensions. So the previous estimate we had from USGS was 150 meters diameter. Right now we're getting a 260 by 115 or by 375 feet, right? So that gives us a little bit better dimensions of that thing, that based on the December 23rd thermal map. So just kind of picking out these important parts of these update for you guys. I won't spend too much time on the text here, but I do want to make sure that we do cover that. So the update from this morning, they say, as of 2 p.m. yesterday, the lava crater lake was still 176 meters deep. So it didn't change from morning and afternoon yesterday, right? And the lake level appeared to be 2 meters 6 feet lower, leaving a narrow black ledge around the north edge. We'll look at a picture of this here shortly. Early this morning, the west vent reactivated, while the north vent quieted and started to drain the lake. Reduced SO2 emissions were measured last night, right? These are all signs of things that we're paying attention to, the SO2, the activations of the vents, right? So, we'll talk about the meaning of all this and what might happen kind of coming up. You guys got questions coming in. But we're going to make sure we cover what the USGS is saying first as like the foundation for what we're going to talk about, right? So they say SO2 last night, rates have dropped to 16,000 to 20,000 tons per day. Summit tilt meters recorded slowing deflationary tilt until just before 3 a.m. this morning, when it switched to inflationary tilt, right? So not nearly as fast or as big as what we saw before, but it is a change we're going to look at as well. Seismicity remained elevated but stable, with a few minor earthquakes and tremor fluctuations regarded to the vigor of fissure fountaining. The north vent continued erupting lava into a lake. The west vent was incandescent, glowing until about 2:40 a.m. And that's about coincident with a switch from deflationary to inflationary tilt, right? So we saw the tilt switch over, the vent starts glowing, then it became vigorously active with up to 3 narrow lava streams into the lake. And then 20 minutes later, after 3 a.m., the north vent quieted and started to slowly drain from the lake. So previous to this, the north vent was still erupting through the edge of the lake, even as the lower part of it had been drowned. So there's our same numbers, 27 million cubic yards. The island over here, now we got an update on the island. The island of cooler lava floating in the lake, which has been drifting slowly northeastward in the lake, has apparently grounded itself near the north vent. So it actually stopped. It is still about 260 meters by 115 meters in width based on the maps. And as of about 6 a.m. this morning, the island started to drift to the southeast. So it's actually reversed course, right? That's something we can look at here shortly as well. So that's our main update from the USGS in the text version, right? That they're putting out on their updates. We'll look at the other feeds as well, Facebook and Twitter, whatever else. But let's look in more detail at the last 24 hours here of our thermal camera. And let me give it a reload, just to make sure I have the most current imagery here, because these things do update every hour. And while I wait for it to load here, it seems to be going unusually slow. Give it and try it again. And we'll just work with what we got here. So, okay, this is the last 24 hours, right? So it's starting Christmas Day evening. And so by this point in time, the island has already parked itself over here near this northern vent, which you kind of see is still erupting at the beginning of this sequence. And then actually, the island starts moving back to the opposite direction over here. And at the same time, down in this area, we start to see the reactivation of those vents. So if you kind of look at where I've circled down in here, you can see it comes up at the opposite time as this one. Right? So that's kind of the pattern we see there. But as usual, kind of want to take you guys back here and show you a little bit more detail. So here's where we are now. And I'm going to rewind us a little bit here. And you can see that this vent is active not that long ago, right? And you can kind of see the pattern in the lake is not that much different over here. So we come down to this one's actually not even updated all the way, so my apologies for that. I'll go back over here. And yeah, this is the one that really shows that switch over from that spattering vent on the north side to the one on the northwest side. Okay, so let's move on. We have images from yesterday to catch up on as well. So here is an image of that northern vent when it was still active, right? So this is a vent, let's see what the early December 21st, right? So approximately 2:30 a.m. on the 25th. So at this point in time, this vent is still active. It's not all the way submerged yet. And here is the vent that is currently now, today on the 26th, erupting. Right, so right here you see, this is the one that's been reactivated since then. It's been now pouring lava in this direction. This is the one that's shut off in the last day. All right, so let's kind of review what else is posted by the USGS here. Here's how they're measuring their lava levels with their rangefinder. See the highly trained HVO geologist here. using a tool that many golfers use, to estimate a distance there. Of course, there's this maybe probably a little more fancy, right? But you can kind of see that's basically all based on distance measurements and knowing where they are and all those kind of things. Some questions have come up on Twitter that they've answered about that. So here's kind of a wider angle view. You can see the upper crater rim right up here, right? You can see there's a lower piece of block down here, a lower one down over there, and that's kind of those inner nested craters that we have within Kīlauea caldera today. Zoomed into that, that's that northern vent there, still on December 25th, right? Kind of still spattering. You kind of see it's all this black stuff on the outside. That's where all the lava is landing, the droplets and what we call the spatter of lava is landing. And it's kind of piling up above the lava level, but this is also fresh lava, and it kind of see it's coating the walls a little bit in some areas, depending on how the wind and gases kind of blow it around up there. And it's from here that we have those kind of pieces of finely spun glass, right, that we call Pele's hair. It's like a natural volcanic fiberglass almost, right? Like a spun glass. It's not unlike a cotton candy. When you see the cotton candy getting pulled apart and making those fibers and filaments, you see the similar thing. The lava gets stretched out and makes those fibers that kind of break off, and that's the kind of light material that can get carried way up in the wind and blow miles and miles and miles away. And that's what we've heard was falling in an all downwind area of the eruption, all through Pahala and Ocean View and Na'alehu and areas like that, southwest Hawaii, south and southwest Hawaii. So we'll move on here in the pictures. Another wide angle view here. You can see that the evening of December 25th, I'm going to zoom in. You guys can get a better view of that one since it's 6 p.m. here on December 25th, right? That northwest vent still not very active, right? Incandescent, glowing, but you don't see any fresh lava coming down the side. You do see all the black new stuff all along the edges, just like the other side, right? But no fresh lava. Well, you do see it's hot and glowing in there. The gas is still coming out, and there's probably lava not that far down in the hole, right? It's just there's, for whatever reason, it's still making its way up and out, as we now know, retroactively looking back. So we also have this image, which is a comparison slider here. And so they're just now comparing between December 21st and December 25th. And so you can kind of see here's the 21st, 6:30 a.m. and here's the 25th, 6:09 p.m. So I'll kind of go back and forth for you guys and just give you a visual idea of how much the lava lake has filled in the last 4 days. 4.5 days is what this is showing. I'm going to do it a few times for you guys to enjoy. Right, so now we're up here. And yeah, just a dramatic change. It's really an amazing thing. There's a few places we can see the Earth change at this kind of pace that we live our lives, right? And day to day, and hour to hour, and month to month. So here on a 26th. You can see this is an image of 2:40 a.m. and 2:40 a.m. is when that northwest vent reactivated, right? It rejuvenated and started coming down. That's what we saw, read in the report, and we don't really see anything happening anywhere over here on this side. Yeah, so you kind of see that change in the pattern, and kind of we saw a bit of the video of that to start off the broadcast here, but you see the still image of what that actually looks like captured, right? And it's interesting to note, we'll get to this shortly as well, but there used to be a lower vent for this fissure as well that was down here under the lake. And it's interesting to kind of wonder, well, if this one were reactivated, what's going on underneath the surface down there? Well, we can only wonder at this for now. So here's that aerial view again. Now we're looking, come back here. Now we're looking at the daylight image. Oh, come on, what are you doing? That one was user error. I apologize. Okay, so here we go. Here's that northwest vent putting out the lava rivers. There's 1, 2, 3 holes, right? There's kind of this. The right one is putting out 2 different little rivers. Dare I try to zoom it in again? There it is. Okay, so there it is. Now you can see those 3 little streams perhaps right in there. There's 1 and 2 and 3. And this middle glowing vent, and this particular photograph doesn't seem to be putting out any lava. And then here is our northern vent, not really showing anything red or glowing in the daytime. Of course, all this, you gotta remember, is also liquid lava with a crust on it, right? And it's also not showing us any glow, because in the daytime you just don't see it. You have to wait till it's at nighttime to kind of see that incandescence coming through the cracks and the thinness of the thin areas of that crust. Because naturally, as it moves and convects around, naturally it pulls apart and stretches and crunches together in different places like that as well. So, okay, let's zoom back out and look at, this is a fascinating image. We've been looking at the thermal imagery, but this is now taken from the air, looking at a different angle. So we have now a view of the drowned, submerged northern vent and the northwest vent, right? And you kind of see, now we can kind of see, it looks like there is a third river, little trickle stream coming from this middle vent going down, and one from the more eastern vent, and one from the more western vent right there. And so that's essentially what is happening that we can't see from the regular webcam view below that lip in front of the view. Okay, so zoomed in photo of the crater lake, and this is, do we have a time here? I don't have a time, but this was this afternoon, or sometime in the daytime today. And what you can really see now is, besides this inactive north vent, you start to see this accretion ring, right? They often call these bathtub scum rings, right? Or a lava accretionary ring. Essentially what's happening is the lava level is dropping. And as it's dropping, the lava that's above is freezing. It's basically just staying frozen in place, right? You know, it remains as like a levee. Like a high water mark, a high lava mark, you know, and you kind of see this at other craters around, you know, Kīlauea, for example, as well. So that's an interesting thing as well, and you can see that forming around the island here as well, this kind of black ledge. And black ledges were quite famous to the history of the lava lakes in Kīlauea. They almost always get them at some point in time, right? But basically having this accretion on a margin, and you can kind of see there's a distance up and down there, and maybe I can get Dane to jump in here and tell me what the distances are, how far down this thing has dropped. You know, we had a report earlier in a report, and you guys just update that it was 2 meters, 6 feet. But what are we at now, Dane?
7 feet was the latest I saw in the USGS comment section. Which, for those that don't know, like, the USGS alerts and the updates they do formally on the page are amazing, right? But really, the comment section in USGS, when they put something up and then start responding to people, that's a gold mine right there. And it was true in 2018 as well. So what they were saying is it's 7 foot down from the bathtub rim, right? Mm-hmm. The high point down to the lava lake. But then you have the rafted island there that has a 20-foot drop down to the lava lake.
Right. So that thing is tall. It's got its own height.
Right.
I gotcha. All right, so thanks for that, Dane. So that's kind of a little bit more about this image, and Dane's got some annotated images up on Hawaii Tracker with our evening update today. So that's the images we have from today. Maybe I'll reload it just to make sure there's nothing else that popped up here since I've been.
You up for some questions right now?
Yes. Let me finish this page, and I will take some of these questions because I think they relate to what we've been talking about, and I just want to make sure we kind of cover the bases here first. So. So this one here is just released, and it says 1 image every 10 minutes, and this is showing the shift in activity earlier today. So this is the same video we were looking at earlier, but it's kind of it's showing it in better resolution. So this is fantastic. I'm glad I reloaded this. Let me zoom it in some more too. All right, so there's that northern vent, and you can kind of see the circulation is coming from this direction, right? See, this thing's putting out, right? And now suddenly the circulation changes. Now it's coming from here. And that was pretty sudden from what I saw. I'll do it without drawing on it now for you guys to see. Yeah, it's fascinating, yeah? And so that's one aspect of it is like the circulation of it is changing. And, you know, and it's interesting because this island was being drawn towards the feeder source. So it was kind of pulled towards this vent right in here as this one was active. And now suddenly this one becomes active. And look, here it comes scooting back over this way. So this is almost like an indicator of which way the flow is going, right? To kind of see which, you know, this thing had went as far as it could towards the northern vent, kind of before it parked itself. And if you look at this small piece, it seems to be attached at some shallow depth, right? Because they move together. Yeah, unlike some of these other little ones over here. Right. So that's fascinating. Thank you once again, USGS. And now we have an image here of the geologists measuring the lake once again, and the depth being 176 meters after last night being the peak depth of 179 meters. So they're saying now it's a three meter drop, right? That kind of answers that question a little bit more too. And that says peak depth was yesterday at 9:10 p.m. local time, right? For anyone who's wondering, you know, when that actually happened. So since then, it's essentially been dropping, right? So that was before the that's the peak measurement, right? So we don't know exactly if they were, they weren't measuring necessarily every minute to tell us exactly which minute it changed, but that's more or less when it was switch, when it was the high point. All right, look at this picture taken by N. Bennington at 5 p.m. today, so 2.5 hours ago. And it is showing, look at that, rainbow, because, I actually live somewhere over here underneath this rain cloud. In my house, it's raining, and up at the summit, it's nice and clear, and look at the nice rainbow right there, right? You might even see a second part of it, I'm not sure over there, right? But now you can kind of see, maybe I can zoom in even more. Let's see how far it'll let me go. Okay. Right, the bathtub scum ring, there and there, right? Even this little one's got it. Right, it looks little, but this thing is probably massive, right? If this thing is 200 meters long, then this is like, bigger than a bus or something, right? But our northern vent is still looking cool. I don't see any kind of even bubbling or churning or anything happening really right there, right? We don't even see it. It would be nice to see if there's any kind of action happening in here at some point in time. But our northwest / western vent, depending on how I've been saying it, you can see it here, looks to still be active and vigorous, putting in the lake, especially this kind of the two ones on the edge. The middle one is putting out this little trickle still, right? But these essentially are all one crack, right? One crack that's got the fingers coming up once again. And those of you guys who've been following us for a few days now or longer will recall that we've been talking about this possibility of lava rising to this level and actually draining back in here and then shutting off this vent. And the one possibility was that it might actually come out the other finger because the one blocked off, the other one was still open. And we now know from USGS 111 feet higher. So the lava has a path out here still. And we're still discussing and trying to, learn more about exactly why it's draining back here more so and not coming out here and all that. So, but that's what's actually happening. And so that is the last image of the day from the USGS. And so let's turn to some questions now. And let's see. Dan, you want to throw me some questions from our viewers on Facebook and YouTube?
Sure. So Michael Phillips from Weatherboy and Big Island Press Club asks, the lava lake is now well above the water table that was feeding the water lake?
Yes, it is indeed. Yeah. The water table is still there, but it exists kind of all surrounding where the lava's come up essentially now, right? So the lava kind of burned its way through the water table. And that was when we had the most fear of explosions happening, was at that point in time, because, depending on how fast the lava came into the water and how much water it could vaporize all at one time and then be trying to come up through the rock all at once, that's when you might have like kind of the highest likelihood of a blast, right? And so we got through that without the blast. The lava actually came up, the crater wall, poured into the actual pond, with the pond, but, wherever the actual crack that fed the wall, the crater came up, it came through the water table also, right? Just off to the side a little bit. Right, so kind of the combined effect of that burned that hole that essentially is underneath that feeder zone now, and so there's still water table underneath that, underneath Steaming Bluff over here and Volcano House and other areas that are farther away, right? I don't exactly know how big that buffer zone actually is, right? But once we get past that initial stage of the magma coming into the water, how quickly is it going to come? And it's actually just kind of going through it now, and it's kind of burned its way through. Any water from the groundwater trying to flow in from the sides, it's not gushing in. It's moving in slowly enough that we can kind of entrain it, and it becomes steam, and it comes up as part of the gas of the column as well. So yeah, that's a good point, and that's kind of why we'll show you guys later. USGS has put out FAQ on explosions, and explosions are a lot less likely now than before, and that's because of that. We have a new equilibrium, essentially, that allows the magma to kind of go through a place where the water table no longer can get to. Yeah, so that's kind of the long answer to that.
So next question is from Damon Tucker from Big Island Gazette. Live panorama of Halemaumau and the down drop caldera block, the down drop caldera floor from the west rim of the new summit collapse features KW Cam. What is this? That's a quote from USGS. He's asking you to explain what is the down drop caldera floor.
All right. Okay. Let me go to. I'm gonna go to Harry's picture because you can see it. It's no longer dark in there, right? Okay. So this is what Damon is referring to on this webcam right here, the KW Cam on the USGS webpage. They've now updated the caption to say Halemaumau, lava lake, and down drop block. The down drop block is this piece of land up here. So this piece of land right here that's bounded by that crack that's kind of the closest one to Volcano House. There's this piece of land that's a down drop block. So they're saying lava lake, crater, and down drop block. That's the answer there. This is important because this time the lava erupted through the wall of the crater down here, but it could come up through the wall over here. It could come up through this block through here. It could come up anywhere through here. And so that when I suppose they're trying to be more accurate in their description here. And of course, this panorama used to say Halemaumau Summit and Water Lake, and so they have updated the captions. Maybe they're doing, they're just taking it to the next step further from there. Next question, Dane.
Right. So the next question is from Mike Penzool. Mike Penzool. If the second vent ends up getting submerged, do you believe the pressure will build up and result in a new fissure erupting?
It could. I mean, that's one possibility that could happen, right? It could. It all depends on the dynamics of how much gas is trying to get out, and how much lava that's gas poor is trying to get back in, right? So the lava that's gas poor is quite a bit denser, heavier. There's still gas in it. It's just gas poor because a lot of it's been vented off, as it comes up, as it gets thrown out. I've been talking about my champagne bottle analogy. We pop the cork, the gas comes flying out, it brings a liquid with it, the gas escapes never to be seen again, liquid falls back down to the ground. In this case, that's the lava. So the lava comes back down as flat, so to speak, and it's going to drain back to the lowest possible place, which is the bottom of the pit, until there's suddenly a drain over where it can reach. So that is that's the dynamics there. So if the lava level rises another 100 feet, right, which at this point seems something else has to change first for that to happen, then the northern vent may act purely as a drain, and possibly you could have lava bubbling through the lake at the northwest vent, or it might be easier for it to bubble out of the north vent, or it might shut off altogether. And if it does shut off altogether, then it's a matter of, okay, it's shut off altogether. The longer it stays shut off, then the harder it is to break away back through. And the next time you come at it, whether it's a month or longer, you got to make a new path up, push your way through along a crack. I mean, there's plenty of cracks already there, but you got to find a new. The magma's going to start over. It's no longer going to be fluid and mobile at that point. You can't just push the stuff that's already there like a water pipe and just have it just move out the front and you keep going. You got to go around it. That stuff is hardened underground.
All right. One last question for this round. M.Ice from YouTube asks, is there any history of summit collapse on Mauna Loa? How might an event like this affect Kīlauea and the volcanic plumbing further down rift to the ERZ, Eastern Rift? So it's kind of two questions there. If you want to try and take that just briefly on both. All
right. So Mauna Loa has a summit caldera as well, which is massive. Very, very big summit caldera. So the fact that it's got a caldera means that it has had summit collapse. That's how the caldera actually forms. So for sure, yes. And in fact, we know that there are big, very dense blocks of lava up on Mauna Loa crater rim, almost at the exact summit of Mauna Loa. Very close to there, you can find these big, dense blocks that have no bubbles in them at all, which means it was a piece of rock that had to have cooled underground, right? A magma cooled underground, and then got thrown up onto the rim, the highest point of the caldera rim. So not only have we had collapses, we've had big explosions there as well, and I think that's something that an area that has ongoing research, We really have to ask the USGS experts about that in detail, but that's the answer to your question. Yes, there have been collapses there. There seems to be a pretty interesting connection and a balance of pressure at Mauna Loa and Kīlauea, especially when they're erupting, right? There have been eruptions of Mauna Loa in the past where Kīlauea crater floor is bulged upwards at the same time as Mauna Loa is erupting because of what Mauna Loa is doing. And so it can get really, really weird and interesting how they can kind of interact with each other. But that's part one. So how does it affect the volcanic plumbing farther going down an east rift zone? That often is a matter of what other consequences come of the eruption, right? Because Kīlauea essentially is on the southeast flank of Mauna Loa. And so when Mauna Loa pushes it to the southeast, it can actually push Kīlauea. Kīlauea has its own southeast flank, and if it moves as a domino effect, then you can have eruptions that can happen on it also. For example, 1868 is a great example of that. There was an eruption in Kahuku on Mauna Loa's southwest rift, right? That's an area of Hawaii Volcanoes National Park you can visit today, the Kahuku unit. You can go and see that 1868 fissure. It's not that far from where you go into that area. That was there were two earthquakes that were kind of associated with that event. There was one that was about somewhere around magnitude 7, and one that's about magnitude 8 that came afterwards. And the magnitude 8 earthquake in particular is thought to have not only shaken Kīlauea caldera and caused collapses. I believe there was a small eruption in there as well. Yeah, there was. Yeah, and it also moved the south flank, opened the east rift, and caused eruptions. Small eruptions, very brief, very small, localized, but along most of the rift zone all the way down. So that's like an example of like the most extreme case, magnitude 8 earthquake that goes along with Mauna Loa trigger and how that affects Kīlauea, and then the east rift zone is like being the second domino, right? Kind of Kīlauea summit's the closest domino to Mauna Loa, and then its southeast flank, and therefore its east rift zone that kind of is bounded by the southeast flank would be the second domino to fall. All right, so there are that's our first round of questions here, and let's see if I can pick up where I was, and we're going to go to some other questions that USGS has answered online. And so USGS now has a FAQ page. If you go to their main website and right at the very top, look at their eruption information, they have an FAQ link. You can find that as well. So I'm going to kind of pick a few questions out of here and point them out to you guys and kind of read here. So a little bit. And so right here is one we kind of address. Will there be explosions because of water? Since a water lake boiled away in the initial stages of the ongoing eruption, it is less likely there will be water-driven explosive activity at Kīlauea summit. Though geophysical studies show that a large area underlying Kīlauea summit contains groundwater, most Kīlauea summit eruptions over the past 200 years have occurred without explosive activity. HVO is monitoring the situation closely for any indications of a change in activity type. Right, so they're not ruling it out entirely because something can change. We saw in 1924 is kind of an example of that, where we had an earthquake that caused everything to drain away, and then after that you started having some more explosions kind of as a consequence. So it doesn't mean that's something that could happen at some point. There's no indication of anything like that happening now, but it perhaps happened in the past, so we don't eliminate it as a possibility entirely. Right, that's kind of a really extreme thing that happened. Of course, before the 24 collapse, we had the lava at 1,000, at basically filling the caldera to the fullest it's been in the last 200 years. So it was a different situation than we have now, where we're basically following the largest collapse we've had in the last 100 years. So it doesn't exactly relate, but it's we don't want to close the door on something that we don't know enough to really say about yet. So, all right, they kind of point out their monitoring feeds over there, and here's another question I want to take. Can you tell if the lava is feeding up from the bottom or only flowing down the sides? And here is the answer, right? And to go into this a little more, let's look at this December 21st view from the south, also thermal. So here's a north fissure, right? Kind of hard to believe the lava levels come up all the way to here now, right? There's a side of the lava lake in comparison now. And we actually had an upper vent in the west and a lower vent in the west. And we had a middle vent. And that middle vent on that lower down drop block had a small little fissure as well. So we actually have missing this one, and this one have all been buried prior to yesterday. And now we have this one also buried, right? And so the question, or the answer there, the eruption initiated with 3 fissures in north and northwest walls of Halemaumau crater between 7:30 and 8 a.m. on December 22nd. The middle fissure ceased erupting and has since been inundated by the growing lava lake. Since then, lava has been only visibly erupting from the 2 remaining vents on the sides of Halemaumau crater. We are unable to determine if the middle fissure has reactivated, as it is submerged. And there's your short answer. We are unable to tell. We don't know what's happening under the lake. If we saw bubbling coming from those sources, like an upwelling source or something like that, that might give you an indication, well, maybe there's lava coming out of there. If you saw some kind of, circulation towards it and things draining away, maybe to something also, right? But the mass that we have in there is mostly not showing us any of those things. It's mostly showing us filling to that northern vent. It's been dominating the whole story all the way now, right? So next question is one we get a lot, and it's worth answering this every time because I know that this eruption is causing a lot of anxiety for the residents of Puna, especially, right? And we started, for those of you guys who may be joining us, just in the last, just this year for updates, we started off doing updates, as a community service for people in the Lower East Rift Zone during 2018 eruption, right? And so we've kind of upped our production a little bit since then. Before it was really guerrilla style. We'd be out in the field with just whatever we could get and flashlight and generators running, and it was kind of we did what we had to do to get information to our community, right? And so now we had more time to kind of, prepare. And, of course, this eruption now is nothing like that because no one's life's being threatened. No one's house is being threatened. The biggest impact really is a gas, and we will get to that because it is an important big impact, right? But it was, it was a different situation then. We just had to get things out quickly. So people down there are still very traumatized from that, how quickly everyone had to respond. Not only did we have to respond with updates, people had to respond with moving everything out of their house and, saving their pets and all the other things that kind of went with it. So the trauma is real. And so the question comes from there. Does this mean that the Lower East Rift Zone will erupt again, right? Of course, the answer is it's going to erupt again someday. I think that the question more specifically is, does this mean it's going to erupt during this eruption, right? So the current activity at Kīlauea summit is confined to Halemaumau crater within a national park. Modern data show no changes to the Lower East Rift Zone or other parts of the volcano. Seismicity and ground information associated with the eruption have been concentrated at the summit. The data indicate that eruption is stable, and HVO is closely watching for any changes. So they're watching. If anything does change, we'll see the signals, but there are no such signals now, as I also have been saying. So just a couple more. Does lava entering a crater through the side fissures indicate the 2018 vent is blocked? And they basically say that it's coming from a different location. When magma migrates upwards to the surface as a dike, it does so along the path of least resistance. Crater walls are the preferred path of opening versus a crater floor. That's based on the stresses that surround the craters. So that's just how it happens. It's just, it might not seem counterintuitive. And a follow-up question that I have, we have had a little bit of discussion with some people. This does not mean that the lava level underground is higher than the cracks where it's coming out of now. It's still way below there, and it's actually forced its way to the surface through a pre-existing path that was weak enough for it to push its way through. And basically, when that happens, then the gas can start forming its bubbles, and it starts rising to the surface. And when it happens, it's going to have to come all the way out. It's like a champagne bottle. If you put a crack in that cork, you've popped it, essentially, right? You either pop it or you don't. You can't kind of pop a champagne bottle. So it's a lot to do with the gas as well, right? So, all right. A couple more questions here. Will the floor of the crater collapse like in 2018? And they say there was a lot of intense deformation in 2018, and there's nothing like that today. Unlikely to have another collapse. They're basing it on the monitoring right there. They have a question: how long before the lava lake reaches the rim of Halemaumau? All right, so we talked about this a little bit as well, right? But they are talking about the rim of Halemaumau a little bit differently. So let's read their answer first. Based on an average eruption rate from the first 2 days of activity, right? You got to base it on something. And assuming the eruption rate remained constant, that's the assumption we also had to make because that's what you need. And we know it's not true, but that's the thought game we're playing here. The entire area that collapsed in 2018, including the down drop block. So here in map view, here's our down drop block. Once again, Damon, there's our down drop block right there, right? So our camera is kind of positioned over here, the KW cam that's looking off in this direction. All right, so that's why we see that other vent is kind of right below. We can't quite see it, and we can see this one a little more easily, right? So that's kind of a little angle. So the whole area, including the down drop block, would fill in about 140 days. So they're saying to fill up this whole thing, 140 days, okay? They're saying the crater itself would take much less time, approximately several weeks. Several weeks is their answer for the inner crater. That means that they're using this line over here as our inner crater, right? Now we talked about when it's going to come up into that first spillover out of the steepest section down here, and that's quite a bit lower. And we came up with a answer of about a week or so, right, from the beginning, a week to 10 days, and about the same time as visibility. So I don't believe, at this, since the lake started draining, we're not going to get there right now, not unless we change the eruption dynamics here. But what we see right now is consistent with a wind down to a pause or end of eruption. So that's kind of what we're looking at this point. And you can see they address, viewer how you view it at the park and gas emissions as well. So we will talk about the gas more as well. But a couple more questions that are related to what you guys are asking as well. And, I want to make sure we have USGS's straight response covered here as well, besides, whatever I might try to add on or, interpret for you guys as a geologist not employed by the USGS. So here we have a question. What happens when a height of the pool covers a fissure? Will the fissure still put out lava or find a weak spot and appear, like in 2018? So this person's worried about it coming back down the rift zone once again. And once again, a repeat of 2018 is not likely for a variety of reasons. But when lava covers a fissure, eruption can continue if the pressure is high enough. Overnight, lava did seem to inundate the lower north fissure, pushing back against that vent. In response, more started coming out of the other, higher level west vent. The volcano summit also started to inflate a little, as if there was some pressure building again in a subsurface. This might result in a push back from that vent, a common occurrence in past Kīlauea lava lake events. So that other vent could actually increase because we're essentially the inflation, we'll get to this a little more later, but it's telling us that the lava is not getting out fast enough, right? And so it's able to kind of build a little bit of back pressure, more than before. Not that much, not that, especially not a lot compared to how much it's unpressurized, but we will show you guys that as well. Okay, next question here. What's going to happen now that lava is raining back in the North Fissure? So, kind of another take on the same answer, right? It's useful to hear things put different ways. So, another way to put the answer here. The effusion rate has decreased, and the summit has started to inflate slightly. That means the Western Fissure can't accommodate the flow the North vent was erupting. So, we might see an increase in pressure and then a resumption. The Western vent might eventually become more vigorous, or the eruption could pause. And so, you guys see that we're all consistent with what we're saying here in our broadcast and the USGS as well. So, will it drain back in 2018? Straight up answer, no. The activity is all in a summit area. Often we see a cycling of eruptions with drain back and an eruption and then drain back once again, like Kīlauea. So we've discussed that as a possibility as well. And so that could be something that happens if we drown that upper vent, because at that point there'll be no more upper outlet for that to come out. It could actually backflow, repressurize, and then erupt again, and then backflow, pressurize, erupt again. And in Kīlauea, that's kind of how it happened over the course of most of the last 20 days of the eruption or so. So, and that obviously slows the eruption rate, slows the release of gas, and can prolong and extend the eruption as well, right? So those are all kind of variables yet to be determined how that all plays out. Okay, so I want to go to the USGS Twitter as well here and kind of make sure we cover all their information feeds, because they're also using Twitter as well now. And so here's our most recent message 32 minutes ago. Lava continues to erupt within Halemaumau crater through the west vents. Gas emissions and seismic activity remain elevated. Closely monitoring continues, right? So there you go. There's an image of the rangefinder. This is something that's worth pointing out. USGS is sharing. There is a Facebook group called VOG Talk. And if you are in our local communities and you would like some answers, discussion about the VOG, that is a new page that's been put up by an international researcher with USGS ties who used to be one of our community members here in Hawaii before she moved back to the UK. So help her out here, join her group and, help the researchers out so we can really document the true impact of the VOG here on our local communities, and then actually mobilize some kind of response, because what we've seen is there hasn't been a whole lot of response to the major impact of this eruption, which is not everyone looking at the glow at the summit and tourism and economy and whatever else people are thinking, but rather all the pieces of glass and SO2 and particulates that are flying downwind of this and have now wrapped around to the Kona side and are actually affecting a lot of the Kona coast as well, right? Beyond just, I can't see my sunset, but actually, it's hard to breathe now. And my school's outdoors. Can I be out here? And what's going to happen when school starts back up? So that kind of thing, those people who have, school is a whole other issue. We'll leave that be there. So there was an update earlier today as well from USGS on Twitter, and you can kind of see here that this is where they say the lava levels decreased by 2 meters, 7 feet. And so we saw a later photograph caption 3 meters. Maybe we're at 10 feet, somewhere like that by now, right? So something else to kind of keep an eye on there if you guys want the most recent information. That's one place to look at it. So the gas impact. We're going to look at the state map here of Hawaii air quality. This is the Department of Health, state of Hawaii. And you can see that overall air quality is green for most of the islands. So we're going to focus on Hawaii Island here today. And let's zoom in a little bit. That works. Let's go move it over here though. And you guys can, I'm going to go out a little bit. I'm kind of on myself here. You can see in Kona, we actually have an air quality of 54, right? We're in a yellow here. And this is particulate matter, 2.5, right? You can kind of see that this is not atypical. In fact, most of the day has been an alert level yellow in Kona, right? Which is interesting. You guys might see that the areas that are closer to the volcano don't, right up here, upwind, almost, no impact. It's measurable, right? But, not anything like 54 or Captain Cook here showing 42 in the green right now. Borderline yellow was in yellow earlier today, right? And Ocean View is one that has been getting a brunt of this, right? So you can see here that we're actually currently in green, but also in yellow a lot of the day today. And I kind of want to rewind for you guys here because you can see that yesterday were actually peaks of around 70. If you could read that, you guys probably can't see my yellow cursor when I wrote a yellow graph, but we're around 70 right there. And we go back 115, 157, right there, right? That was Christmas Eve. So you can see that clear concerns for the impact on the health of our community down in this area right over here. So we actually went, I went down today with a Kikamarzo, and we passed out some of the masks, gas masks, ventilator, the actual cartridge masks that are good for SO2. We passed out N95s in case there's any kind of ash events. We do realize the gas output has gone out from this event, has gone down, but if people are aware of these issues now and the fact that this might renew, or even if the eruption actually ends in 2 days, let's say, this is still something that's likely to happen again within the next year. And you want to be prepared. You might as well be prepared now. There's no time like now to be prepared. So we want to make sure that everyone has that preparation in place, and part of that is access to masks. And so that Kikamarzo has been doing community service doing that, and we've been going out and answering questions. And so I believe we'll be back there on Wednesday is our plan. We can check our feeds for that, more information on that if you're a local member of our downwind communities. So here's Na'alehu today. You can see it was mostly in the green, but it does hit yellow in the mornings, especially past couple of days as well. I can really see that there, yeah. So I actually, when I looked at this earlier, Pahala was showing me a high spike, and it's at green now. Like, see how the wind direction really affects this. This is showing a 9 SO2 reading now, and it was actually at yellow, borderline orange at 37 earlier, and you can see that it was up at 187 at 3 p.m. in the red there for the SO2, right? So the VOG, is this is really the impact to our communities, and it's pretty amazing to me. We have had very, very little response, from our, there's been just, and I wouldn't say this if I hadn't talked to people in the community today. People in the community today are the ones telling us that there's no one else to listen to, that there's nothing coming from civil defense about the gas, that there's nothing coming from the county. There's just nothing. There's just nothing. We did have an alert from the state put out on the 22nd. We'll cover that for you guys here first. But let me show you guys the VOG model, and then we'll cover what the state is saying. So here's our most recent VOG model. So over here on the left is SO2, right? Showing zone of impact, SO2 downwind here in an area of Pahala, more so a little bit Na'alehu and Ocean View a little farther away. So Pahala really maybe getting the worst of the SO2, which is SO2 is typically worse closer to the vent. Right, and if we back up here and go look at the particulates are essentially what after the SO2 is reacting with the water vapor in the air, and especially with sunlight, temperature, those kind of things can actually cause reactions, and that gas is changing into particulate matter that are sulfate particles. Right, so that's what this is kind of modeling here. You kind of see that that's wrapping all around, right, and even into the saddle as well, and the entire Kona coast is covered in this stuff, right? Even Waimea, you wouldn't think Waimea up here would have this impact, right? But because of the way that the winds flow, you have particulate in Waimea as well. All right, so there is the model for all the islands, and you guys can see that today because the winds are the way they are. All of this is going away from all the other islands and basically off into the Pacific, right? Let's look at our stations, National Park Monitoring Network here, and we'll reload it to make sure we have the most recent information. And within the park itself, conditions are good. So anyone who's up there viewing glow tonight is having good air, better air than a couple days ago, that's for sure. Although still, earlier today in Kahuku, you're still seeing the effects, as we just pointed out as well. Okay, last wind map here. This is windy.com. Let's reload it and see how it's actually looking now. I showed a version of this earlier today in a feed with Ikaika, but I might have to actually zoom out because incredibly, I'm not looking at enough of the world at once here. So here we are in Hawaii, and our initial plume was blowing all over here. So this is all SO2 from Hawaii. This is not. You guys are looking at see if you're where this is China over here, and this is China industry. That's normal for people's activity. Hawaii doesn't do that. We don't have that kind of industry here in Hawaii. So this is all the gas plume from a volcano. You can kind of see the interesting thing here. And now I'll zoom back in. Right, poor California is now getting the wind of our SO2 as well. SO2, which of course, this is the SO2 layer, and SO2 is the one that's going to react and cause the VOG areas as well. So you might not only have the smog in LA, maybe less smog with COVID lockdowns and all that, but you do have some VOG to replace it, unfortunately, coming in over here from Hawaii on our pineapple current, yeah. So, all right. There is, like I mentioned before, a DOH release, December 22nd, it was posted. And so they talk about how there was an eruption began on the 20th, 2 days prior to this, and essentially check the online reports, reduce outdoor activities, especially if you're in the sensitive groups, stay indoors and close windows and doors. If you have an air conditioner used, set it to recirculate. If you need to move out of an area, turn on a car's AC and set it to recirculate. Medications on hand. Keep prescriptions on schedule to help protect from the effects. And here's one that we've never seen in a volcano update before. Remember that face coverings and masks used to prevent the spread of COVID-19 do not provide protection from SO2 or VOG, right? So that's why we're passing out special masks, right? Not because people aren't wearing masks due to COVID, but because we need different masks to filter for ash and for SO2. Now, granted, the N95s are being used in a lot of places, especially among our more sensitive communities, like doctors and such, because they do provide that better protection as well. So that one kind of has a double use, as well. So, but for the most part, your bandana style, your regular cloth covering is not going to do it for your SO2. Although, it could be better than nothing. We had people in 2018, thought it was better than nothing. People soaked them in water or soaked them in other materials as well. And if that is an issue, we'll cover that again. But for now, just kind of covering here. Contact a doctor, do not smoke, drink fluids, have plans, heat warnings by the county, your typical stuff, advisories by the state of Hawaii. And for you guys, we're not aware, right? State of Hawaii, everything comes out of Honolulu, which is several islands away from us, right? So we're not surprised to see a 2-day delay in a notice here from Oahu. It's more about the crickets coming from Hawaii Island that were kind of shocking to hear from the people in the downwind communities that we talked to today. So, okay, and they basically say, look at the air quality data website. That's the one I've been showed you guys today. And they have more information here. What does green mean? What does yellow mean? Orange, red, purple, maroon, right? And like what, description, who the groups, what you should do, all that kind of thing. So you guys can check that out as well, right? Department of Health, State of Hawaii. Okay, so we're going to turn to our other monitoring signals. I want to do the gas first today because, that was really there was really something that, I don't know, I've been talking about gas later in our updates, but really gas is the main impact, it was made very obvious to me today and going out and passing out those masks. So thank you guys for sharing, and thank you guys in the community who are doing all your work you do to support each other, in those areas as well. So, all right, deformation data, other signals that are geophysical. our tilt signal here. Let's give it a refresh because it is a couple hours old here. We can see this is a 2-day plot. We're going down. You can see there's our 3 a.m. time frame going up since then, right? It's the rate's wiggling a little bit, but you really can't tell on that short time scale what's going on there. We have to wait to see what's going to happen next with that tilt. So our past week plot, you can kind of see it's, in the grand scheme of things, we dropped down from the range of 30 to -10, -15, right? So we dropped down maybe 45 or so microradians. We've come back up. Look at the top graph, between a little below -1 and a little below +1, right? So about 2 microradians we've come up in the last day, right? And that's on a scale of our deflation-inflation cycles that we used to get before. Some of them might even be bigger than that, 4 or 5 microradians of that size. So there's a scale, it's going to be interesting to see if this is a temporary thing or if this is kind of the beginning of the end, right? Because it could pressurize enough to pop back out more lava out of that western vent. If it pressurizes enough, it could pop out a new vent, a new part of that crack, come up a new piece of the crack in that area. Or it could be that it just kind of, the vent shuts off and it just keeps pressurizing, because the long-term pattern of this volcano for the last 1.5 years and for the foreseeable future is going to be refilling with magma. And as it refills with magma, that thing is going to inflate. And as soon as it stops erupting, that second it stops erupting, I expect it to start inflating again, right? So we'll have to see, that scale and how long and all that, right? And there may be a transition period, right? But sometimes these things happen, just like just turn on a dime. So we'll keep an eye on that as well. And kind of compared to our intrusion back here in December 2nd, you can kind of see how much bigger the signal is we are now in comparison, how small, right? So here's a deflation inflations before that intrusion, and then here's how much we've risen in the last day, right? Barely visible on our plot. So we'll look at the USGS page a little more here. This is the GPS distance across Kīlauea summit, and you can see that our initial drop, like the sagging, the crater walls are coming closer together. Right, that's what's happening here, because they're sagging, because not because lava's coming out, but it's coming out from below, and the below part's deflating, and that's what's causing the sagging at the top. And so you can kind of see it's continued sagging. The lowest data point is way down here. Let me zoom in for you guys if I can. Right there, you guys can see this more clearly, right? It's clear drop, right, all the way to there. And once the eruption is over and things stabilize, you expect to see whatever pattern stabilizing and then at some point going back up as well. And it's all a question of how long does that take to happen, right? And we'll skip the 5-year plot. Looking at Pu'o'o, this is not a distance across a rift zone near Pu'o'o, right? And this is something that's been stable for a while now, although some variations up in here. You can see, looks like beginning to be a convincing downward trend here. Right, and we'll have to wait for more data to see how the response continues in the rift zone, but it appears the rift zone is contracting, right? And we've heard USGS state exactly that as well. There are signs the rift zone is contracting from the monitoring data. And so what I'll do now is I'm going to switch to all the tilt, the more detail of all tilt meters and GPS meters. You can look and dig into that just a little bit more here. And so our 1 month tilt, here's our summit. There's that signal we're just looking at right in there. And you can kind of see other summit stations are showing that same pattern, right? Down, a little up, very slight up over there. This signal is not putting data often enough for us to tell. But here, this one's interesting, right? If we look at the East Rift, 2 miles southeast of the summit. And we'll zoom in to this part of the graph here. And first, before I get it off the screen here, our scale. Every line is 1 microradian, right? This is not like what we just had up here, where every line is 10 microradians, right? So it's important when we're looking at these graphs to make sure we're looking at the right scale and judging our comparisons appropriately based on that. So 1 microradian scale at the escape road 3 miles southeast. So the eruption actually begins shortly before the earthquake. This big spike is the earthquake, the 4.4 on a south flank that kind of followed the eruption by about an hour, I believe, something in that range. So the eruption actually begins right in there, and it's indistinguishable from this plot whether this thing changes trend here or right next to it, right over here. But clearly, changed trend it has, right? you can kind of see these up and down wiggles in it. That's kind of delay variations that occur day to day. So you can see before this eruption happened, you get those also, right? Now this particular station, this is the north indicator, right? So the north indicator is, in this case, based on what USGS has said, showing a change in a pressure going down, right? And this is just based on USGS. It kind of depends a lot on where the instrument's configured, which side of the rift zone it's on, whether the signal actually on a plot goes up or goes down. So this can be confusing, and it's been confusing to me as well. But from what USGS is saying, this is our interpretation here, is that this thing's actually showing signs of sagging, like almost like a deflationary trend, right? Or possibly if this is an inflationary, something more local just to there. But in any case, that trend that began during eruption now seems to be kind of curving over and possibly reducing its slope as well, right? So we'll have to see how that progresses too, going over there. But between this and, well, we don't really have any other tilt meters to speak of because the Pu'u'o tilt meter is offline. The Jonica tilt meter, we can see, has no effect. So the lower east rift zone is not responding in any way whatsoever after that earthquake, that 4.4. That kind of was an hour after the beginning of the eruption. So on the south flank, Mulivaya Pele is offline. Our Kina Point station is offline. So they have some maintenance to do on those. But we can switch to GPS, which we have a lot of instruments as well. Tilt is just only one part of it that's kind of, sometimes even problematic. We've issued warnings before about tilt. So let's look at GPS. And so here's our GPS station by station. And now our stations are broken down by an east component is a top plot, a north component is the middle plot, and up and down is the bottom plot. And so Uekahuna is a station on the northwest. And you can see that rather than moving, this is the east, rather than moving not east to the west, it's now moving back to the east, sagging towards the source, right? No longer moving to the north, away from the source, back towards the source to the south. And also sagging downwards in elevation, right? So that's a summit station. You see the same pattern at the outlet vent. We see the same pattern at Byron's Ledge. The directions of the plot might vary depending on which direction from that station to the eruption site, whether it's north, south, east, or west from the station, right? That's why I can kind of look a different direction there. So the map view is important. I just can tell you from memory where these all are. So we can see here patterns, Byron's Ledge also. These are all summit stations. Crater Rim also showing adjustment, right? Crater Rim's on the south, so it's moving towards the source to the north, right? For example, but also moving down. Right, so that's how it looks. Mana'ulu. Mana'ulu is a place where it's right at the bend of the rift zone. So at the bend of the rift zone, we don't see that signal that we saw prior to the buildup of eruption as clearly, right? So I'm going to skip Mana'ulu for now because it's a little bit of a special case, and I'm going to move further on to Kananui-Ohamo, right? And I wonder if I can bring the map back up. Do I have a map of this? So I'll look at the map a little later. Okay, so Kananui-Ohamo is a place where we were starting to see, not very big in this area also, right? Very small scale, this is in meters, but a little bit of an upward trend in the east. The thing was starting to tip east a little bit. It's more obvious farther away. You look at Kamoamoa. In Kamoamoa, let me show you guys a scale. This is October. This line over here is October. So since October, this thing has been moving more to the east, right? And that's the pattern we've seen there and further east as well. So now I'm going to zoom in, and it's just starting to show up, and we'll expect to see more of this in the coming days. But it looks like this is starting to sag back towards the west, right? And sag back towards the south, in this case, right, at Kamoamoa. And we go to Pu'u'o, and we see that Pu'u'o was also moving east much faster since about October. And we also see signals that it may be sagging its way back as well here, right? Back to the south, over here, back to the west, and the up and down has stayed steady at Pu'u'o. We go to the Jacuzzi station, which is near Pu'u'o, farther south. It's the other one being used for that measurement, and you can see it was clearly being pushed to the east quite a lot more, maybe because it's a little bit outside the rift zone, and it has bounced back quite a lot more as well, right? That's what I'm looking at right in here. So these two data points right in here, how it dropped back down. Okay, so a little further, we don't see it as much at Jonica. And now we're going to move to the south flank, and at Ahua, which is kind of very near the summit, we pointed out that we had seen a push to the east as well. It's also showing sagging back to the west. We'd seen it speed up, pushing to the south. It's moved back towards the source to the north as west as well. And up and down had been rising and actually maybe dropping now, right? Because this is also close enough to be affected by that summit summit area. And so I won't go every single one of them, but you guys can kind of see the pattern. It's true at Puhimau, which is kind of an upper east rift zone as well, right? It's true at Devil's Throat, east, north as well. We don't know at Mulivaiopele, stations offline. We at Makaopui, this is kind of on the flank near Makapui, Makai. So maybe there's something happening. It's within a range of noise. We'll have to look, kind of look at when you see these kind of things happening further back in time. You really don't know if that's enough information there to make any judgment on. The Kalapana Trail, also looking suspicious here at the end, right? This is an area that we've seen was moving south most of the time ever since that 6.9 earthquake, and here it is suddenly relaxing back to the north, right? And so expect that to change once the eruption is over, but that is how it looks today. All right, Hilanapali, a little more subdued, and Maukakepukanene showing a strong push back, sagging back to the north there, right? So we don't always go through these GPS signals in this much detail, but we do like to do it once in a while just to make sure that we kind of are caught up and there's nothing kind of catching us by surprise. As you guys can see, that's the extent of the signal. I don't see it anywhere else in those western stations of the volcano there. So we will switch to showing you guys very quickly the seismographs here, and we'll reload it again to make sure we have the most recent info. And this is last 48-hour plots. So the times are over here on the side. And you can see that there are some time we have a little bit more tremor, like right in here. Look at that, the time, 3 a.m. Maybe I should zoom in on that one for you guys. Right, 3 a.m. You can see the ink gets noticeably darker, right? So there was more vigor in the eruption right there, right? But you can see that before that, it had kind of quieted down, right? Not a whole lot of effusion. You can see after this initial burst between 3 and 5:30, let's call it, it also quieted down for a little while. Picked up a little bit between 8 and let's call it 1 p.m. And then since 1 p.m., you can see it's been was more active until just recently, about an hour ago. And maybe in the last hour, it's starting to lay off it a little bit there, right? So that pattern is probably true everywhere, right? There's our 3 o'clock band, or we'll call it a 2 p.m. band over here. That station we have to skip over. And a little more subtle, a little farther away. A little more subtle, farther away, but we can see the ground isn't shaking that much, right? You see these other little earthquakes, little adjustments here and there. These are probably barely big enough to register on a map. So, okay, what station are we at now? This one is Byron's Ledge. It's picking this up very clearly. Look at these signals here. Maybe some change in a magma movement happening a little further east prior to that 3 a.m. window, right? You notice the time is a little offset there on that one, right? And it does pick up that kind of 2 p.m. to 6 p.m. thing as well. But this one is interesting, right? This one may be our canary here that's picking things up a little bit sooner than the other ones. Keep an eye on this one here. And right now, it is dead quiet over there. So, not surprising.
So you up for some more questions from chat real quick?
Yep, let's do the questions.
All right. Michael Phillips, again from Weatherboy and Big On Press Club, asks, have we restocked our cartridges on our gas masks, just in case? I, for one, have not. I'm still got the ones I had from 2018, but I'm not worried about it personally.
Yeah, you're way upwind. You're fine. Yeah, I mean, although the VOG has changed around, although when a wind changes and blows that particulate matter, For the farther away it is, even though it's really irritating, it's not really that dangerous.
Right.
Unless you're really in the thick of it.
Wearing those full half-face respirators is somewhat irritating too when you do it for a prolonged period of time.
Right.
So next question is from Anthony Quintano. He was the one that was running the Civil Beat live stream in 2018. He asked, we might have already answered this, but with the level reaching the highest level of the fissure, especially the northern one, are we seeing a slowdown, a level off, or will we return to level rising beyond the fissure in the future?
All right. So the main vent was, in fact, not the highest fissure, but just the most vigorous one. And the lava level reached that level of that most dominant vent, the northern one, as we've been calling it, and has now been draining back down that level. So there is another vent to the west, which has taken over, has been reactivated since that first one shut off. And it is putting out lava intermittently, right? It was intermittent before. There's got to be it's harder for lava to get out of that vent, clearly, than it was the other one. Right, but the other one somehow seems to have shut off, that began when it started draining. So, and now it's all the way shut off as it continues draining. So, it could go to that highest fissure, but I'll just kick your question forward. What if it covers that fissure, right? Then what are we going to see? We could see it slow down and level off. We could see it rise above the fissure. We could see it drain back, refill, drain back, refill in a kind of episodic fashion like we saw at Kīlauea without the super giant fountains, right? So that is kind of the direct answer there, Anthony. Thanks for joining us. Next question, Dane. See if we get a question from Dane here.
Yeah, I was muted, sorry. Do the times of seismic activity correlate to the amount of VOG we are getting in Ka'u, or is that strictly about wind patterns?
It is the wind patterns and the emission rate, right? So how much is coming out of the hole in the ground? That's the two things. And how much is coming out of the hole in the ground is directly related to how much lava is coming out. So it's basically how much lava is coming out and the wind direction. There's basically are the two factors there. So the amount of gas coming out, we reported, the USGS report mentioned, is half of what it was earlier in a week. So if there's been any relief from VOG, it could be partly from that. Although, as well, more importantly, the wind direction, right? Even if you have a smaller amount of VOG and it's blowing right at you and super concentrated, then it's going to be terrible for you. But of course, the bigger the source, the wider the area. All right.
Right. Final one for this round. Michael Carey asks, could the lava have found an empty lava tube from an earlier eruption and be draining into it now? And do we know how the old lava is? When I was watching 2018 eruption, the age of the lava was something being talked about. I believe this is talking about the 1955 stuff in the beginning of the 2018 eruption he's referring to with that.
Right. Okay. So, got two or three questions in there. So, the first one: could lava have found an empty lava tube from earlier eruption and be draining into it now? There are lava tubes in a lot of the volcano, less so in the caldera, because the caldera is an area where you have more ponding and less flow. But you can have lava tubes in the caldera, but they're just not going to be very big or really go anywhere in that case, right? So, a lava tube, to kind of recap, is a surface feature on a volcano. So, if you guys live in a northern climate, in the northern hemisphere, that's somewhere that gets cold and rivers freeze over, you may have seen something like this happening, where you have ice forms on the banks of the river, and eventually it'll meet in the middle and kind of crust over the river, but there's still liquid flowing underneath there, right? And so if you live somewhere cold, then when it warms up again, those ice rafts break apart and you have your river back and it's open once again, right? When you have lava flowing in a river, and so you kind of need a river to start off with, you then have a similar effect where lava is kind of freezing on the sides and it closes off the middle, and it basically is encased itself, and that's what forms a lava tube. That area starts off as kind of being flat and short, but as the flow kind of can swell upwards and kind of carve its way downwards, you end up with more of these pear-shaped ones for like the ones that are much older. So if anyone's been to the Nahuku cave system, aka Thurston lava tube in the national park, it has that kind of shape, right? Kind of pear shape of it, and that's the result of we think lava flowing in that tube for some estimates up to 20 years. to carve a tube that big in an area like that. So if it could get into a tube that was that size, maybe is what you're kind of referring to, maybe that could be some kind of path. Those things generally run downhill following the topography. They're not connected to the rift zone at all, right? So lava tubes are generally on an order of, if they're big, they might be, 60, 100 feet tall, right? But they're essentially layered few meters, few tens of feet under the ground. And of course, it can be buried by other flows up and over like that. The rift zone is an area of weakness that's almost like a fault zone, right? Where the island is kind of being pushed apart. It's being pushed apart by magma injecting in, but also gravity can kind of pull that whole south flank, which is the kind of other edge of it, downwards in a way. So it's a structure that at its shallowest, the rift zone is about a half mile down, and it goes down to a mile and a half down. So the rift zone is not a surface feature. So the rift zone and lava tubes do not connect themselves. Lava could go into an old lava tube possibly, and depending on its vigor and all the other dynamics around it, it could possibly go somewhere, right? It could also go into the tube that's full of cold air. Maybe there's even some water in there, and then it could actually just freeze and form a plug right at the entrance and go over top of the ground above that and never go in that tube ever again. So, people who live in Hawaii Island know that lava tubes are everywhere, and you have to watch out when you're doing construction, because you don't want to fall in one, or have your machine fall in one, or have your house, over one, all those kind of things. So that's kind of the part one. I kind of got on a little bit. Part two, do we know how old the lava is? No, we don't, is the answer, right? That's the kind of thing that we need to have petrology done. And so we'll await the lab at University of Hawaii to analyze the samples taken of the lava, right? Well, what samples you might say? Oh, well, there you go. There's a problem right there. We need samples of the lava to actually do the analysis on, right? And ideally ones that have crystals in them that have been brought up from deep in the crater, and give us the full history of that crystal growing in a magma chamber, how long it spent, where it spent its time, and then how it got to the surface, right? So we may have Pele's hairs, like small glassy material from the lava, right? But we don't have those crystals per se yet, right? That's something that once Eruption is actually over, you could, send a drone down and scoop something up, or, throw a bucket over the edge, or, there are people who've done different things in the past. But that's kind of what you need for that. There are ways to analyze a glass also, but it does get trickier, and so that's why we don't know how old the lava is actually quite yet, right? And in the case of 2018, we had samples of 55 lava before that. And then when we got the lava was coming out in the middle of the street. It was really easy to walk down the street and got a sample back to the lab, and there you go, right? And there's another issue of how to get down 1,000 feet down there to get a sample, right? So that's kind of part of it as well, why we don't know the pattern yet. That's something we have to wait for USGS and University of Hawaii to analyze and report back to us in the future, right? So that is the answer to that. And that was our last question, Dane, for this round, I believe.
Yeah, that was it for now. I'll grab some more for you for the end.
All right. So we're talking about the actual side, the tremor, and that kind of leads to questions about earthquakes. How the earthquake's doing. You can see the Hawaiian Island, not that many earthquakes. We still have our cluster down here underneath Pahala. This is the very deep ones. All these are more than 20 miles down, right? Then we have at the summit one, couple by the bend in the rift zone, and one kind of here in the south flank. One southwest Mauna Loa. We have actually a little bit of a reactivation of a couple of small earthquakes on northwest Mauna Loa, but maybe Mauna Loa is finally catching back up from its adjustment and is ready to go again. At least its inflation, what it was doing before, long term with no imminent threat. But this is really the story of the earthquakes. There's not a whole lot to talk about here. We can look at it in a different way. We can look at earthquake counts. So I'll show you guys here at the bottom. This is 5-year earthquake count. So 2016, this is 2018. This is our caldera collapse mostly. And we can kind of see that the level of earthquakes since then has been elevated above what it was before, right? And so we may have right here at the very end a slight little peak, but in comparison where we were before in a scale of 5 years, it barely also registers as coming above the background of what we have now. So we have to zoom in more, and that's what this upper plot here, the 1 year, is for. Zooming in on the last year, we can see that we've been building up in earthquakes, much more, especially October, right? And then December, right? So that's kind of the view kind of building up to the eruption. But what's happening now here at the end, we got to zoom in more. So I'm going to scroll up here and show you guys 1 month, right? So in the last month, earthquakes kind of ramped up here to our intrusion event. That intrusion is just magma injecting into an area underground, wedging itself in there underground. And it kind of dropped off again, but kind of stayed a little bit elevated. And then here's our slight increase that we got for our eruption that began on the evening of the 20th. And you can see that since then, we are down to no earthquakes. Why? There's nothing. We have an open path. There's, we're relieving the pressure rather than building it back up and forcing things to move around. So you might have some earthquakes still happening. It's not zero. There's something happening just from the sagging, right? So, so there you go. And that is the earthquake. And so kind of want to scroll up a little bit more here and then show you guys some more of the SO2, right? So we kind of talked about earlier on, this is the rapid SO2 plots that the USGS has up on their page. And we saw, you can see their spikes kind of peaking up here at their stations close by 50 ppm SO2, more recently around the 20s, but clearly we're having gas outputs measuring there, and a little bit lower, less than 10 ppm at this other station over here, but they are kind of picking that up as well. All right, so moving on, we're kind of getting towards the end of our signals here, and I give you guys a little bit more history, and you guys can have stayed with us to the end here. I want to show you guys this most recent USGS map from yesterday showing lava depth in meters. So we peaked at 179 in the end. This is showing 175. You kind of see the vent, this one a little lower, this one a little higher right up here, and extent of the lava level as it is there, right? So, all right. I want to show you guys one more time. I kind of covered this in the last couple updates as well, but image put out of the USGS on the 23rd showing Empire State Building and how it might feel, the size of the old water lake, right? The water depth before, 50 meters, current lava depth, and at this point was 158 meters. We're now up to 180-ish, so maybe somewhere in there, right? And we kind of talked about this as a intro to like how fast might the lava actually come up, how long can it keep it up, how far does it have to come up to actually spill over the edges, like the crater over here, for example, right? And we were saying it's got to basically be somewhere right up around here, and it was really a big question whether it could sustain that for that entire length of time. Right, so that's what we're going to turn to now, is then this whole what's going to happen next debate, right? We don't know, but we're going to just show you guys some of this background. This is the effusion rate, right? How much is coming out of the ground at any particular instant, right? And then we have here what we call the eruption rate, the average over the whole length of time. That kind of has the same area under the curve as this curve right here, right? So that we have that volume over this amount of time. That is basically how you do it, right? So when you're looking at old eruptions, you don't have this data of like what happened minute to minute, hour to hour. You go with this, and so it's important to kind of differentiate what we're talking about every point in time, right? So our eruption rate, effusion rate, this is what relates to the SO2, right? This is kind of an after the fact all in all. So when we make our projections, we're kind of using this, right? When we're using, when we're talking about how much is coming out at any moment in time, we're talking about this effusion rate. So we do expect, in theory, a quick ramp up, and over time, eruption to kind of gradually die off, right? Theoretically, right? And we discussed as well how, depending on the dynamics of the eruption, that can happen more quickly, right? A little less quickly, or really quite slowly in this case. And so that's one of the questions we still have left remaining to be seen. What style of drop in this effusion rate are we going to see, right? Is it going to actually slow to a trickle and last a long time, or is it going to keep this more rapid decline and at some point sooner? We just don't know the answer to that question. In any case, we can kind of see that if the USGS reports that our SO2 levels are half what they used to be, and they relate to the emission levels or to the eruption levels, then this highest SO2 level was measured this is the halfway point for the eruption rate that would correspond. So we can say that we're probably at least this far down this slope already now, right? We've come up, and now we're going down. Right? So the question is, how does it look afterwards still? And that's kind of something to be seen, and that determines whether we see the whole thing actually stop off, close off entirely, drain and restart. All those dynamics kind of have to do with that as well, right? Like essentially how much is coming out of the ground is essentially the most important factor as well, because it's the gas that's driving all the eruptions, right? And once the lava is degassed and flat, it always wants to go to the lowest possible place. And first it was a pit, now it's a hole in the ground where it actually can reach. All right, so we're gonna look back at look back in time and at the case study of how Kīlauea caldera has collapsed and refilled before, and I find this part to be really interesting. This is my source here. There's a paper by USGS, Evolution and Deformation Studies in Active Hawaiian Volcanoes, right? And this is a paper that was began by Bob Decker and then finished posthumously by HVO staff here, but 2008 590 is a report here. If anyone wants to go and look it up and find some of this info, right? So. All right, first to kind of set the scene, I want to show you guys, this is our contour map of Kīlauea pit now, right? So I'm not showing any lava in here. I want to show you guys at the bottom of the pit is at 520 meters elevation, right? So that's the important thing here to note. And we'll move over to the next image here and show you guys this plot. So if it, I'll back up, 520. So 520 is here. Our max was 179, we'll call it 180. 180 plus 520 is 700. So 700 meters is about close to the level of the high mark of lava. So if I look on here, 700 meters is this line all the way up here, right? That's how full this thing is with lava now. Okay, so we're going to compare this to how it looked before, right? 520, 700, okay? So back in time, meters above sea level, where it was the elevation of the surface of Kīlauea caldera, right? 700, where we are now, is down here, right? So if we went to 2020, this is where our data point is now, right? In this plot, we're only showing back to 1820. We do know that in 1790, there was a big eruption of Kīlauea. There was an ash cloud visible over the top of Mauna Loa, visible from the other side of the island in Kona, right? Don Swanson has gone and looked at the Hawaiian oral tradition, and we believe that there are ponds of water that were at the bottom of that collapse pit, which means this collapse in 1790 went as far down to reach the water table and form ponds, not unlike what we just saw in 2018 to 2019 to 2020, right? So you might say that the water table was down at our pond was 520, 50 meters above that, 570. So somewhere down in here, there's a data point for 1790. This thing had to come up somehow to here, right? Ever since then, you can see we've been at the lowest was somewhere around 700, 1868. I mentioned that event, right? When we talked about the patterns of Mauna Loa and Kīlauea together, right? You can see that huge effect on Kīlauea of that earthquake, right? And this is actually showing a little bit more information. When you have two lines connected by a solid line here, that means the lava lake was active and rising, active and stable, active rising, active dropping. The lava lake was there that entire time. When you see it drop, like stop right here, no lava lake, right? It actually stopped erupting. So you have a few little pauses in the lava lake, but for much of this time, from the 1820s to the 1920s, we had an almost continuous lava lake most of that time. And this is what we often refer to as the 100-year lava lake, right? We did have some gaps in it, right? Notably there and there. But that's the 100 years of lava lakes that Kīlauea caldera is famous for. That actually was a birth of tourism to Hawaii. People like Mark Twain came here, and Isabella Bird, and we can go on and on and on. People came here to see this exact area of activity. So after that, we don't have it in table form, but in 24 we had a big explosion and collapse. After that event happened, we were at 698 meters. So today we are at the similar level as the bottom of the 24 collapse pit, right? That's interesting to note as well. We'll look at that in a different cross section as well here. And I won't go through all of this, but you basically can look at 600, 700, 800, 900, 1,000, 1,000. So that's essentially how we've built up to what most people realize, or understood or knew or recognized as the Halemaumau of 2008, where the lava lake came into, and lava lake was present till 2018, right? So this is kind of where we were at 1,000 meters above sea level elevation right there, right? So, but there's another source here, and it's actually Thomas Jagger has a publication back in the 1940s. Jagger does everything in feet, so I'm going to show you guys a very similar map here. I'm going to show it to you guys in feet now, right? So the bottom of our pit in feet is 1,700. I think I got to change my color again. Or maybe I'll just leave it, right? 1,700 feet is what it says, that right in there. We have filled in about 600 feet of that. So we're at about 2,300 feet. So in this image, our level is right around there, 2,300 feet. That's our shape of our lava lake today. 2,300 feet, okay? And the bottom, 1,700. So we're gonna look here. This is a plot drawn by Jagger. 1909, you probably can't read this, 1909 on this end, 1935 at this end. So these are all 1 year, right? And what's plotted here is the depth, right? Or elevation above sea level of the lava lake in Halemaumau. So you can see all the 1900s, you had a very high lava level most of that time, right? The lava lake was overflowing a lot of this area, and this is a lot of some of the paintings I showed you guys yesterday, lava lakes overflowing come from this area right in here as well, right? The 24 collapse and explosion right down there. You see that drop, and there was a small eruption in 24, but there also is some rubble happening, some landslides happening in here as well. So you can kind of see it went down to below 2,400 feet above sea level, right? By Jagger's calculations, right? And we now, like our collapse went down to 1,700, right? So our lava level has come up to 2,300. That's where we are now. We're at the bottom of this plot today, right? All right, so you can kind of see that there were 7 eruptions that kind of raised the floor of Halemaumau over time, right? And those are the eruptions that we're going to look at in a little more detail. We're going to maybe zoom in a little bit here to 24 to 34. You can see a little bit more detail, right? Here's actually a landslide that kind of raised the bottom artificially during one of their quarters of measurement, but there is an increased pattern we're going to look at in more detail right there, right? Because we've actually come all the way 24, I'm sorry, what did I say? Let me go back to the plot, I'm confusing myself. To 2,300, from 1,700 to 2,300, right? In this one eruption just right now, right? So, all right, let's look at some maps. This is a map, 1924, of the actual gravel flat, the collapse area at the floor, on the floor of Halemaumau there, right? So you can see that the collapse there, 2,300 feet, and that's about where our lava lake surface is today, is this elevation of this piece of ground right over here from 1924, right? So in 24, it was different because it wasn't this full-fledged caldera collapse we have now. It was a smaller collapse, but it was still interesting to see how it actually reformed. There was an eruption that happened earlier, a few months afterwards in 24, that put out a very, very small amount of lava down here on a floor of the collapse pit. Now, when Jagger describes the 24 collapse, he talks about that he could see places where the lava had injected between layers. He could see sills and laccoliths exposed in a wall of the crater. And like once in a while, those things would collapse and tumble down. All these red rocks would start, glowing rocks would fall down into the crater. And the thing would glow red until it solidified black again. You can still see it was hot, but it was a different situation there. There was that was an era following a lot of lava injection, lava lake overflowing. The lava was a very high level. You had lava kind of in pockets all over it inside of this pit and the edges. So it could easily be that this first eruption may have been a remobilization of some of the lava that was left over in one of these voids, pockets, the sills, the areas that was underneath all that pile of mass that got collapsed down and then got squeezed back up again. Like stepping on a toothpaste tube or something like that, just squeeze up a little bit more, right? So that 24 eruption is not clear whether it fits into the pattern of this refilling event or not, so we're going to kind of just move past it here. But you kind of see it was a fairly small thing. It only reached as high as 2418, right? So in 1928, this is showing expansion of flows here. You can kind of see we had more eruptions there. 1924, 27 eruption. right? But we also are showing what he's calling landslips. There are now landslides which are coming into the crater, right? And the reason is that the entire time this is happening, the volcano is repressurizing. It might depressurize during these eruptions, but as soon as eruptions are over, they start repressurizing again. And as magma is refilling from below, it can actually push and tilt the ground above, and then suddenly your crater that had a stable wall, suddenly it's tipped, and that wall falls in. And so if we start seeing landslides in the future, that's going to be another indication that the ground underneath is tilting. We now have tilt meters, and Jagger didn't have nearly the resolution and precision that we have, right? And the models and the GPS and the INSAR and everything else that goes with it. But he did have landslides, and he actually writes, like, if there start being landslides, that's pretty soon you might have an eruption. So that's something to kind of look for in the future, as kind of if things get plugged back underground, this eruption stops and kind of what pops out again. That's kind of thing to look for in between those eruptions, right? Kind of to show that the next one is coming. 29. You can kind of see the pad of lava is getting bigger and bigger and bigger, right? So the collapse pit clearly was a lot narrower. It wasn't nearly as wide as our 2018 collapse pit, and that's why it's filling up this shaft, like, at a different area than we have in 2018, right? So in 29, we now have this whole area over here. I didn't put this out. I'm going to back up here. I'm going to back up to the 29 eruption. So the 24 eruption came through the rubble here somewhere near the bottom. All right. The 27 eruption came out of a vent over here. I'm going to pour down onto the floor there. All right, this one came as a series of fountains across the floor of the crater, across the old lava flows. And so you can kind of see the pinning, that lava flow on top is just like it's just a layer of rubble that can be pushed out of the way. And so you could get lava pushing through there again, and that happened in 1929. And we'll go forward to the second 29 eruption that was also kind of two small eruptions of 29, but this one you're going to see the cone is up here on the side, right? And it's kind of flowing down into the crater as well. So you guys by now have been following us. If you're still watching our stream here, and over an hour and a half in, and you kind of know that this is very similar to what we see today. We've been seeing these patterns a lot, right? But we're now up to 26. The cone here is at 2,700 feet, right? But most of this pad is down at 2,600 feet. So we're not quite to the level of the lava lake we have today in 2020 yet. All right, so 1930. Okay, there is another eruption. It appears to be coming out from here, but look, it's not reactivating that event, which already exists at a higher elevation, not below the pond, that happened just the year before. Right, so that's fascinating. Something to kind of watch out. If the thing stops, it doesn't have to come out the same vent. It could actually crack right over to the side. It could crack through the lake. It could crack on the side somewhere. That's why this is where the answers that we're hearing are coming from. These possibilities of reviewing what's happened in the past, and especially these intervals. And I think this is a perfect case study. The refilling of this 24 collapse pit, 31 to 32. All right, so here is a high point. All right. And you can kind of see that the vent is, in fact, kind of over here again, where it was a couple years before that, right? But we also have some cracking, and over here, a collapse happens afterwards, kind of gets depressed inwards, right? You kind of end up having more tilting in the crater. You can have areas that after the lava comes out, if the lava comes out over here, then over here it could sag in, or even over here, you can have, that's something that might happen if the eruption shuts off for us entirely. You might have sagging at that lava lake surface. It might crumble in some places. And here we are to 1934, which is one of the last biggest. This is the 1 month long eruption that kind of capped that 7 eruptions in 10 years of refilling of Halemaumau post the 24 collapse. And so here you can see the high spots, right, and kind of see. We're now covering an area that looks a little bit more similar to what we're seeing today in a pit of Halemaumau, and we're actually now at 2,800 elevation. So this flow put it higher than we are today, and so we can look at this one more way. The last thing we'll look at today, before we take more questions here, You can kind of see in cross section. I'll zoom in to start. Right down here, 1924, 27, 28 is just this one little lens right over here. 29 is most of this stuff right in here. February, 29 July is this one. 1930, 1931, 1934. All right, so that's kind of how it looks. I'm going to zoom out a little bit so I can show you guys the height here on a side, right? Because where we are now is 2300, right? So the bottom of the collapse pit, right in there, right? So we basically, our lava level was like this, and our pit went down to 1700, like that. So that's kind of what ours looked like on the same scale of cross section, right? But it's interesting, the volume we have filled through here, we mentioned was 27 million cubic yards, right? And so we actually can go back and calculate if we add 24, 27, 28, 29, 29, 30, 31. This amount of lava that came in here was also estimated to be about 27 million cubic yards. An interesting coincidence there, huh? And so you kind of see how we maybe in our 2020 eruption have done an equivalent amount of what took the first 6 in a similar pattern post 2020. But they still had a gap. In this case, it had a 3-year gap. Then you had another eruption that kind of put another 100 feet on top of that. And that's kind of the pattern of how it refilled over time, just filling layer, 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 layer until eventually it got back up to that almost 1,000 meter elevation, right? So that is the story here for the crater refilling. That's the little bit of history we'll throw right here at the end of our update today. And we will leave it at that. Just to remind you guys, we are brought to you guys by Hawaii Tracker, hawaiitracker.com, on Facebook as well. And you can kind of see here, we will take more questions, but I just want to let you know, we are brought by Hawaii Tracker. You can find more like evening update that Dana wrote up here, some different graphics, that he's annotated on there. You can kind of see a little bit more detail in writing, kind of review some of the numbers we've put out, and it's kind of compiled from USGS information as well. So check that out. We'd like to, we'll talk more about this in a second here, but I do want to take some questions, and yeah, Dan, hit me up with some questions when you have some ready.
Yep, there are some ready. These are a little bit different. I think we've gone through most of the stuff, and as relating to this eruption, so these are a little bit off topic, but still on topic. First one is how did Jonica Station get its name? Any relation to the old Jonica store near the jail in Hilo?
That's a good question. I really don't know, to be honest. We do have the Jonica Station named after the Jonica Flow, which is a flow in that area where it is, and that flow may well have been named after that jail. So I believe there may be a connection there. But that's the first I've heard of it, so thank you. I can maybe look it up, but I don't know actually the history of that. Yeah. If anyone in our audience knows more about that, please feel free to add it in the comments. We'd love to hear.
All right, so there's 2 questions I'm going to combine into one. They're both about Loihi.
Okay.
And they're asking about that you mentioned that you were going to do talk about it a little more about Loihi. And another one asks, isn't there any anything related to the movement of the tectonic plates in the hotspot with Loihi in particular?
So I mean, Loihi is connected to our hotspot, and maybe let me bring up a map. Let me find a map here to show you guys. Maybe I'll bring up the earthquake map if I can pull it up again. That's not it.
Right, we didn't have any Loihi stuff prep for this.
Yeah, I mean, I can point, Loihi did have an earthquake swarm was it March of this year, Dane? March 2020, I believe.
Those ones, yeah.
If you go back to March 2020, we did do some streams there as well, and they are on our, probably easiest to find those on YouTube, Facebook. They're kind of buried in there, but they are there, or on hawaiitracker.com, right? And we actually go into a lot of detail about Loihi. I showed you guys underwater footage of other eruptions. We showed you guys the topography down there, the kind of life, all the submarine footage. So if you want to know about Loihi more, really, you should go check out that update, right? As far as today, more briefly, on our map here, let's see if I can change my background. There we go. And let me transition to my map here to show you guys. So this is our earthquake map. I just changed the background on it here, so you guys can see that down here. This Nope, that's not it. It's the seamount down here to the south of Loihi, right? So this is where the eruption actually is. It's kind of offshore. We believe that the hotspot kind of feeds. No, actually, I'm wrong. This one over here. It's Loihi right here. This is Loihi right here. So my apologies. Sorry, Loihi. If I zoom in on you a little more, even on this underwater, I can see your summit caldera underwater right over there. I can see your northeast rift zone. I can see your south rift zone, right? And I'm not sure about the one over here. But that's Loihi right there. Okay, this is some other older piece of seamount riding along on a crest. So we believe the hotspot is actually centered somewhere in the zone of where these earthquakes are, right? These deep earthquakes right in here. And from there, they feed Loihi and Kīlauea and Mauna Loa, right? Yep. That's the source of it right there. And so...
and that's still unknown, kind of. Like, we just want to hedge that bet a little bit because there's so much... The questions around that Pahala area where these deep quakes occur frequently.
Yeah.
And what's the exact connection and how does it work? And there's really no, like, if you see a deep quake there, people are like, oh, there's a deep quake swarm in Pahala. Well, it's not really going to correlate very well to any of the other volcanoes. That's the interesting thing about those swarms, as far as we know so far.
Right.
You know, maybe to a point where we get into high-level data processing with, you know, machine learning, and then we find out there's some pattern that exists that, you know, humans didn't recognize. But, you know, as of right now, we're not there yet.
Yeah, exactly. Yeah. It's been a little nebulous, the connection there. Yeah, there is a connection. There is a delay. The delay seems to be at least many weeks, if not months. You know, just kind of based on what we've not seen happen after that happens down there, right? So. That's Loihi. No changes on Loihi. You know, basically Loihi's been quiet since last March. Yeah. So, but yeah. So, you know, basically, you know, when it comes to the movement of the hotspot, let me address that part of it in particular, right? So, the hotspot is thought to be here, right? Kind of in general, and a Pacific plate moves to the northwest in this direction, right? So that's why. Most of the Hawaii Island is to the northwest, right? In fact, all the Hawaiian Island chain is all northwest, right? All this kept moving that way over top of the hotspot that has, at least recently, more or less stayed parked over here, right? It may not have been as parked when you go further back in time and you see some combined effect of things actually tracking going over here, but that's a whole other story for a different day. We won't get off on that tangent today, right? But so in that sense, the plate is moving this direction. Loihi is showing the youngest spot, the newest spot to pop up on the fresh plate that will then connect to Hawaii Island or possibly start forming another island over here. And so that's how Loihi connects to the plate, is that it's the newest, the youngest, it's still underwater, and that's kind of, you know, that's basically it, right? Of course, you can kind of see it based on the islands, these things stack on each other, so it could also attach to Hawaii Island in the future as well. Yeah.
All right. So next one from YouTube. When was the last time lava was in Fern Forest and Eden Rock area? Generally speaking, you know, don't need to date the flow.
400 years ago.
400.
400 years ago, yeah. This part of what's called the Aila outflow. It's connected to the Kīlauea Iki area. There was a lava shield over top of what's now the crater. That used to be the top of the volcano, was a big hill up there. And it flowed down through the Thurston lava tube, in fact, Nahuku, right? Through that crater and through the Kazamura cave system that goes all the way down to HPP to, I believe, 80 feet above sea level. That's, you know, the Kazamura is, let me see if I can get this right, the longest continuous, active, intact lava tube known on Earth today, because, you know, there are longer ones, there are collapsed, like there's other ones as well, but it's basically it spans in a straight line. I want to say it's like 22 miles or something like that. So that was a huge flow. That, you know, lava lake was spilling over top from the summit, over top of what Kīlauea is now, and it was running down all the Puna all the way to the ocean, right? So all of HPP, also all the way HPP, Eden Rock, Fern Forest, is all that flow. 400 years old. Ish. 1560, right. 1640, that's kind of the range of time, depending on exactly where you might be in that area.
The next one I'm going to kind of take, and I'll let you expand upon it or correct it.
All right.
What is the definition of tilt? So we're talking about tilt meters, right? And first, I'm going to just talk about what is tilt measure versus measured in microradians. So we're talking about angles here. And 1 microradian is worth basically, what was it, 1/60th of a degree, right? And it's basically if you took a board that was 1 kilometer long, right, and placed, what was it, a dime or a nickel? I can't remember which one. It was either a dime or a nickel underneath one edge of the board, and that angle change is 1 microradiant, right? And when we're dealing with tilt meters, that's the unit of measurement we're dealing with, and it's also basically measuring which way the ground's going to tilt, right? And you can measure inflation, you can measure deflation, and a bunch of different things. There's only one really weird system about it where if it goes straight down, it can't see that, right? If it goes literally just straight down, there is no tilt around it change, which is highly unlikely, but that's one of the limitations. But it does see the east-west, the north-east, like all the different angles that it could tilt. You want to expand upon that any?
I think you did great. Yeah. Yeah, that sounds great. That's basically
right.
it. It's how the ground is moving in response to the magma, right? And the why, right? The why is because magma is coming in and magma is going out, and it's an underground thing, right? So it's what's going on underground. Yeah, good job.
Final question here. So the crater has gotten larger over the years because of the collapses.
So the 2018 was the big enlargement, right? If we look at the collapses that happened, the last big one, that had water at the bottom was 1790, right? So since then, the lava level has been kind of filling and collapsing a little bit and filling, collapsing a little bit, filling, collapsing a little bit, filling, collapsing a little bit, filling, collapsing a little bit. Right, of which the last collapse was 24. And the reason I focus on that particular data point is because we had world-class scientists here taking notes for that one. And we didn't have that so much for a lot of the other ones. So we don't have that level of detail over there, right? That's, why we look at the, these old tomes, right? The Origin and Development of Craters by Thomas Jagger. Yeah, we have to pull out off the bookshelf for this kind of thing. So yeah, most of the enlargement was 2018 is the short answer there. But they do kind of collapse over and over, and some bigger than others, and then they might get refilled. The next one might be smaller, the next one might be bigger, kind of just depending. That kind of varies, but the long-term pattern: big collapse, refilling, and big collapse. And so we had a big collapse. Now we're in a refilling with little collapses in betweens. So,
all right, well, that does it for us on the questions. I'd like to thank some of our contributors and supporters that have helped donate to keep Hawaii Tracker going, to keep Philip and I doing these types of presentations, to keep the information kind of flowing on Tracker and, maintaining all the stuff behind the scenes, right? There's a lot of work that gets done on that type of thing, and supporters like this, kind of make it possible for us. So we're just going to go through some names: Sue M., Robin M., Kelly O., Mary Bell M., Alexander R., Betty M., VLS, Rika R., Tess C., Nancy F., Debbie P., Linda B., Jessica N., Robert G., Judas H., Marine F., Lisa W., Lisa G., Mary M., Jasper L., Deb S., and Stacy M. and Nina S. And again, if you guys want to, support us directly, the best way to do that is at hawaiitracker.com. Just go to the support button. And again, we're trying on the hawaiitracker.com, we're trying to do something that not only is able to, exist on social media, but it is its own social media community, right? We want to build that type of network of influencers, community scientists, and everybody in between, people with a cell phone that are in the right spot at the right time to capture, an event going down. We're trying to bring all the people together to keep information flowing at a very efficient rate without a lot of the BS that you see online, and without a lot of the flame wars, without a lot of the conspiracy theories, right? We're trying to get straight down to it. And if that's the type of stuff that you want to support, do so on hawaiitracker.com.
Yeah, here's a donate button right over here, right at the very top, right at hawaiitracker.com. And then if you're an advertiser and want to check out our advertising plans, we would appreciate it also. There's a button up here for that as well, and you'd be happy to discuss with you guys a little further about that. Yeah. Yeah. So, yeah. Thank you guys. Yeah. Just let's a very quick add on to what Dane said. Right. There was. I remember we were in Hawaii Volcanoes National Park right after it had reopened in 2018, and we were trying to go live because there was a little collapse and there was water flowing down the wall of the crater. We're trying to figure out what was happening at the time, and Facebook went down. Facebook was down all day that day, right? And so this is kind of we need to make sure that we're always there for our community, and we just have to make sure that we can control that flow of information as far as having it exist, even if things change with Facebook in the future as well, right? So that's where we're building some resilience for the future as well. So mahalo you guys for watching our stream all the way to the end here. I hit the 2-hour mark. Mahalo for you guys who have donated. Thank you guys for tuning in. We'll hit you guys up on any more of the comments, questions on the comments. Thank you guys for sharing, supporting us. We'll see what happens in the next day or so. Maybe we can do a shorter update tomorrow. Or perhaps if there's not a whole lot of activity, we might wait until after the weekend and come back to it on Monday as well, just because that allows more family time here in this holiday season. Of course, if something dramatic happens, we will come back to you guys, of course, live and keep you up to date. So any final words, Dane?
Nope. I think it went well tonight, and this was the first night that we really went live on multiple platforms. We're coming to you live on Twitter, Facebook, and YouTube. It's great to be able to try and get, different communities, different viewers, different people, people of different interests to be able to find these types of, information. We know how much, we know kind of how the internet works, and things go viral based on sensationalism and hype. We're trying to do the opposite of that, right? We're trying to give you the real analysis from people that live here, that have, and people like Philip that understand the deep, geological speak that even, USGS would do internally, right? That's the type of, information we're trying to bring to the table, the stuff that's, works on the street and works in the academic community too, right? And we're trying to bridge that type of gap. So I thank everybody that tuned in on all the different platforms, and we're going to be trying to, step the production quality up each time.
Yeah, we started off, just for our local community, but we've just seen that the interests in communities are worldwide, right? And and of course we're not chasing after people's houses now, so it's a little easier to do that, kind of bring that in the era of COVID. It's not so unusual. So thank you guys, and mahalo. If you guys keep supporting us, we'll just keep doing better and better.
All right.
So with that, aloha everybody. Mahalo for joining us.
Aloha.